A couple of days ago, I created a video to explain that if-else statements and switch statements can be refactored to classes or enums as long as their type code was not used within the body of those structures. Today I created a different example in which this type code is used in the bodies of the if-else statements, and therefore just creating an enum or just creating an external class is not enough for refactoring. In this case, I will use polymorphism to refactor this example, and in particular I will show how to implement the strategy design pattern. So let's have a look at this code. This class is some sort of insurance which allows you to check, or allows the client to check, if the person is eligible for the insurance. The method that it has here is very badly written and hard to understand, and is not very maintainable. So what I want to observe first in here is that in order to refactor here the type code person, we can see that it is used within the body. In here, also in here, in here, well, in here, and even indirectly here through this object, depth, because the depths, we need the depths from the person, etc. So what the strategy design pattern says is that in order to make a class more maintainable and more easier to test and easier to scale and extend, we need to separate its state from its behavior, so that behavior is interchangeable. In this case, the behavior which is in here can be separated in multiple strategies. One strategy to determine if it's eligible based on a criminal record, another to determine if it's eligible based on a credit record, or based on a medical record. Each of those are candidates for strategies. So let's start doing this. To start refactoring to strategy, the first thing we need is an interface. So we will create an interface, and so let's create that interface. I'm gonna call it eligible strategy. In this interface, we need some method that the client will call, because the strategies that we are talking about are strategies to determine if the person is eligible. Then maybe this signature here that we have is actually what we want in the interface. So let's create this signature in the interface, and let's implement the first strategy. So the first strategy is going to be based on criminal record, right? So we're gonna do a background check on this person based on its criminal record, and if we say that this strategy implements eligible strategy, so we must implement that method. We can see here that it uses some dependency called criminal record finder. So we will need that also. So let's include it. Criminal record finder. Let's inject it. And now let's implement that strategy. So what it says, it basically says that the person is clean if the records are empty. Well, it says the opposite, but we can put it the other way around. So we can say criminal record finds, check person. If the results are empty, then this person is then return true. But apparently this is not enough, because also there is a logging. So we need to add that log also, because it's part of it, of the strategy. It checks and it logs. So let's add that dependency to that logger. Oops. Oh, I think it didn't add it properly. Let me, sorry. We added the constructor parameter, yeah. And let's do that logging. So it logs like this, right? So I'm gonna log here. And I'm returning false. So this would be the implementation of that first strategy. Let's create the next one. So the next strategy I can see here is based on credit history, right? So credit based, or based, sorry, I started call it based on, so based on credit, implements eligible strategy, and when we check that this person is eligible based on its credit, we can see that it again uses let me go back to that screen here. So it again uses this credit history finder. So it depends again on something. So we need to depend on that. So let's say private credit history finder, and I can see no logs. So we don't need a logger. We just need this. And what is going to happen here is going to check if it has depths, right? So let's first get the depths for that person in the same way as they are doing there. And simply, if the depths are empty, then the person is clean, right? So that's fine. But also, it wants to understand if the person has depth, but have just one depth. So because it says that the depth size is greater than 1, and the depths are not of type student loan, then it's not eligible. So basically you are allowed to have just one depth as long as that depth is a student loan. So let's do that. So maybe we can say in here that the depths, we can stream them. Let's stream and add a filter and say for each of these depths, please make sure that so if you have it, so it's not empty, so you have a depth and the depth is equal, sorry, not the depth, the depth type is equal to student long. Okay. And also is equals to student long. Okay, that you have one student long, and we said that the depth size is just one. So this could do. Let's leave it like this for now. I think it's suggesting us here something. Let's leave it like this. So this would be the strategy for the second kind of condition that they have in there. Let's do the next one. So let's create based on marital status. So this is just a demonstration of the strategy design pattern, how to refactor that. The logic is less important. Important is the methodology. So implements, we said eligible strategy, and for the marital status, okay, for some reason it checks the medical record. So medical record finder, alt insert constructor, and let's have a look what is happening here. So it says, let me close this window. Okay, so if this person is a widow, okay, this is quite a strange thing. So if the person is a widow and suffers from depression, but if it is a widow but only if it suffers from depression, then it's not eligible. Otherwise it's eligible. Okay, so let's implement that. So medical record finder dot or sorry, we can say so if the person is equals widow, then medical record finder dot suffers from depression person and does not suffer from depression. So if it doesn't, so if it's a widow but doesn't suffer from depression, returns true. Else return true, right? Because there are no other conditions. So that's it for this this strategy. Now let's have a look in here now. Now that we have that, we have implemented all our strategies. We can use them in here. How are we gonna do that? Well, we are no longer gonna need these things here, but we will probably need a new constructor, and this constructor is gonna depend on different strategies. So here is where it comes, that part of this, the flexibility of this pattern, where we are saying now we can easily decide, as long as the person is over age, what are the kind of background check-ins that we want. So it's kind of plug and play all those background checks that we want. So let's create a field here with the eligible strategy. And now that we have it, we can, let's say, in here, oh sorry, not in here, but in here, eligible strategy dot, let's put it into a list, so we can as list, so we can stream it later. Oops. So a stream dot filter eligible strategy es dot is eligible, who, the person, and we could say that count, so it will return us the amount of strategies that have matched, and if that count is equal to, let's say, the number of eligible strategies in total, so if it passes all the checks, then this person has passed the background checking. If not, then return false. So that's it, basically. Now we don't need anything of this. Of course, if this was wired to some other code, we would need to check. We would start replacing to the new constructor, etc. But this was just a demonstration how to do the strategy and how to refactor to polymorphism when the type code used is actually modifying the behavior of the class. So yeah, I hope you found this useful, and thank you very much.